Hello, class. Welcome to our lesson today dealing with section 4.2, which is basic principles and concepts and probability. Remember, section 4.1 is just some review questions and vocabulary, so I've incorporated those into today's lesson. First thing to start to understand about probability is the idea of what is an event, a simple event, and what is known as the sample space. So an event is all the collection of things that could happen. So the idea of like pulling a marble out of a hat and then figuring all the different options for that, drawing cards from a deck of playing cards, things like that. A simple event is basically you've taken every event down and made it in such a way that you can't break it down anymore. Okay, and it's just saying like these are the versions that we deal with. Simple events are typically what you start with in probability, and then we get into this more complicated event pieces as we go through. A sample space is a list of all the options that are possible. When we first started doing probability, if you think back over the years, we used to draw out sample spaces and write them out and all of these things and then count how many. We're going to do one of those as we're looking at kind of a heads-tails situation on a coin toss. But overall, you want to be kind of moving away from the drawing of the actual sample space and writing it out every time, because the numbers are just going to get so large it's going to be almost impossible to do that. Okay, notation. Notation for probability. P always represents probability, and then typically capital letters represent the events that are occurring. So if we want the probability of event A, probability of event A would be P and then parenthesis, capital A, and then end the parenthesis. And it's basically just how many times did that occur divided by how many total outcomes are there. That's the most basic way to determine simple probability. Just figure out how many options work with what you have divided by how many total options there were. And that should find the probability of any event. You can also look at something that's known as relative frequency. Now, if you think back to relative frequency in a distribution table, what that was looking at how many work for me divided by how many of the total options were there for the frequency distribution, which is essentially just find the probability. Okay, so when we deal with relative frequency, we're saying how many work out of the total, and then that comes from some type of like toss the coin a bunch of times or roll a die a bunch of times. So if you think about it, the more times that you go through a process, the closer you should get to what should actually happen. Anyone that's involved in any dice rolling in a game or something like that knows if you roll a die 5 times, you can get some pretty strange results in 5 tosses. But if you roll that die 500 times, you're going to get more and more like the probabilities that you're expecting to happen. So that's the difference between a few choices and options versus a lot of options, because you're going to get closer and closer to what the true probability should have been theoretically, the more times that you go through an experiment. Okay, so this is just another way to show the probability of an event. How many ways can that event occur divided by the total number of different events that could occur in all the options, not just your event A. So for example, roll a 6-sided die. If I say I want the number 1, well, there's one way that can happen out of the 6 faces of the die. Let's say I want an even. There's 3 ways, 2, 4, and 6. So that would be 3 out of the 6 ways, which is 1/2. You're probably going to see a lot more fractions than anything on these smaller questions. When you get to larger numbers, it's probably going a decimal route. But just things to think about as you're going through probability. Okay, the probability that an event that is impossible to occur is 0. Probability of a certain event is 1. Going along with that, every probability that you ever find should be between 0 and 1. So sorry, the 0 is cut off here, but it should be between 0 and 1. Okay, so between those two, and this makes sense. The probability of an impossible event is 0, which means that's the lowest it can go. Probability of a certain event is 100% or 1, and most likely it's in between those things. There's also something known as the complement. Now, there's lots of ways to write the complement. Okay, the complement is A with a bar over it, or A with a kind of a C for an exponent, or A, and we call this A prime. Okay, A with a one tick mark is A prime. This means the probability that the event doesn't occur. So for example, if I say find the probability of rolling a 6, and the probability you don't roll a 6, that would be its complement. In general, okay, the complement and its corresponding original event should add up to 100% because you're either in this group or you're not in that group, and it should add up to 100% or 1. Again, for probability, when you have to find a decimal, probably 3 significant digits, which basically means until you get to a number. So it could be like 0.000 something and then 3 digits. But a lot of times you're also going to leave things as fractions. You'll want to make sure that whatever calculator you plan to use, you can switch things around and know how to deal with that to make things fractions as opposed to decimals. When it comes to certain types of calculators, when you get to higher fractions, you're going to have to go kind of old school routes about simplifying because your calculator can only do up to a certain number, around 1,000 typically. So that's something that you might want to think about as you're going through these questions as well. Okay, so this is tossing a coin 3 times. So I toss the coin, see if it's heads, tails, toss the coin again, heads, tails, toss the coin a 3rd time, heads, tails. First thing before we get started on anything else is let's not get into this what if scenario. Well, what if it lands on its side? Okay, first off, I wouldn't believe you. I know it could land on its side, but I probably wouldn't believe you. But even if it did land on its side, we would just call that a redo and a re-roll. This would be no different than when you roll a die and it lands on the crack between pieces of a table or something or off the board. So that would be the same idea as you're looking at those situations. Okay, to find a sample space, you just have to think about it and write them all out, or I like to use this tree diagram idea. What this says is for the first event, I could have got heads or tails. If the first one was heads, then the second event, the second time I roll, it could have been heads or tails off of that. And then if the first event was heads, the second event was heads, it could have been heads, tails off of that. And that's 1, 2, 3 events. And I just do that for all the cases. And then I literally just follow every path. So heads, 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 tail, heads, tail, head, etc. And that's how I get these 8 options. So the first thing that you want to realize is there's not just 3 options, okay? It's not just that you get all heads or all tails, things like that, because there's multiple ways to get some of the versions. Okay, so if I want the probability of all 3 heads, there's only one of the 8. Okay, all 3 heads is this one out of the 8 options. But if I wanted 2 heads and a tail, there's actually 3 ways to do that, and because it doesn't matter which one was the tail. Think of it this way, if you win a best of 3, okay, if you're playing a game and it's best of 3, you just have to win 2 of the 3. It doesn't matter which 2 you win. So you could win the first 2 games, you can win the last 2 games, or you could win the first and the 3rd game. So there's 3 ways that you can make that work, even though they are different outcomes. When you collectively put them together, they're the same final outcome, which is why that's 3 out of 8 instead of 1. This says there were about 42 million cars, just under 6 million were involved in crashes. So if you want the probability of a crash, you would just take how many crashes there were divided by the total. Most likely, when it never gets that high, it's probably a decimal question. If it is a fraction question, you might want to just cancel some zeros out and start with that. But most likely in this situation, it's probably going to be a decimal. Then this says find the probability of not a crash, because remember the line, the bar over it means not, okay, or its complement. So essentially just take this 6 million or this 5,960,000 away from the 42 million number and then still divide by the total. But what should happen here is these 2 answers that I find when I put them together should equal 1 or 100%. And the reason for that is an event and its complement are kind of separate, but then they add together to equal everything. Okay, so they should add up to 100% because either it was involved in a crash or was not involved in a crash to make it the 100%. Next question, you're asked about your favorite meal. First step in a lot of these questions, just add up and find the total. So I made this one pretty easy to find the total. 277 plus 200 plus 523 is 1,000. That's got to be your first step. Students that prefer breakfast would be the 277 out of 1,000. That's probably a fraction question. You can see if that simplifies it all with your calculator, but in this case, it probably doesn't. Students that prefer lunch would be 200 out of 1,000. Don't forget that needs to simplify down. Always simplify your fractions on these questions with probability. The directions will say either write as a decimal and probably go to 3 significant digits, which is just after all the zeros if it's a really small probability, or it's going to be write as a simplified fraction. So you want to be comfortable with those 2 situations as you're going through your homework and getting ready for any test. Okay, just to show some certain or impossible events, probability of the next leap year is 2024. Well, the next leap year is 2024, so that's 100%. Find the probability Thanksgiving will be on a Wednesday. Well, Thanksgiving's on a Thursday, so that's 0. Unless the government decides to change the date to a Wednesday, then it would become 100%. But in its current setup, it's going to be 0 because Thanksgiving is on a Thursday, not a Wednesday. Okay, so that was a lot of technical information and definitions, and just a basic intro to probability. I think you'll find this first section fairly easy. What we're going to look at in our next section is dealing with what is known as odds. And odds is a new topic that, causes a lot of issues. And so we're going to look at that in our next lesson. And then once we get past section 4.2, probability really ratchets it up and gets a little bit more challenging because of all the different dynamics involved and all the different numbers involved. So you want to make sure you have your scientific calculator. You want to make sure you're paying attention to where the buttons are in your calculator as we move forward into the next couple sections. And then make sure you know if you want to find a decimal or fraction and how to simplify if needed. Have a good day, everyone.